Say record.
Okay, now we're good.
All right. Good morning, Alex and Hunter and Brandon. Today we skipped it for you, but we just did this problem. A 67 meter per second projectile is launched at 52 degrees. What is the range? How far does it go in the x direction? And we did all that with finding acceleration time and so forth in the x direction and the y direction, and we actually put the two together and came out with this answer. It was a very long process. We did not tape it for you. However, today we're going to simplify that and come up with what's called the range equation. So let's develop the range equation. So we're going to be mathematicians for a few minutes, and then we'll go back to being physicists, as if they never overlap. All right, so the equation for how far a projectile goes in one step, it will involve this trig ID. So even my trig students haven't had this trig ID yet. Calc students, you've had this trig ID. Does it look familiar? The sine of twice of angle equals 2 times the sine of the angle cosine of the angle. We're going to need that little nugget of truth in the middle of our development, so I just put it up there as way of reminder. So let's go ahead and develop this formula. And you'll recall that as we did it the long way, first we worked in x, and then we worked in y, and then we came back and worked in x. What were we trying to find when we did it on the y side? Do you remember, Zach, what was our goal when we were working in y?
The distance?
No.
Oh, wait, no, time.
Time, because we needed that over on the distance side. So we had to work in time, look for time. So I'm going to start my development with time. And I'm going to use this equation, which, remember, after trying one of them and failing, we did end up with that one on the y side. So I would like to put in some values, because this is tracing it's tracing the steps that we use to find time. That means this was in the y direction. So I'm thinking in y as I go down with this equation. So I know that some of the values are already, because the velocity in the y direction final was 0, because that was when we were at the peak at the maximum height. What was the velocity initial? Well, it was whatever the velocity initial was times the sine of the angle. And when we got to acceleration, it's either negative 9.8 or negative 32, so I'm just going to call it g. Negative g. That is the standard abbreviation for the acceleration constant due to gravity. And then time is time. All right, any questions? So in the most general way, this is what we did over here. Before I erased it, we had actual numbers here. I would like you to take that and solve it for time. So we want time to be by itself. So, oh, mathematicians, enjoy this side and move this over, divide by that, and you get time equals. So when you solve that for time, Brian, what shows up in the numerator? That up there? Okay.
I'm trying to catch up.
All right.
Just writing down some things.
Okay. Zach, can you solve that for time for us?
Time equals initial velocity sine of theta over g.
All right. Notice this would have been negative when he pulled it to the left, but he divided it by negative, so the negatives drop out. So please note that g is positive here. So if it shows up in our final formula, we will put it in as positive, because we already took care of it being negative up here. So you'll see that when we get down to it. All right, so that's all we can do on the y side. So now I'm going to go and work on the x side, and at some point I'm going to need the time to do that. So keep an eye on the time here. and we'll pull it back down in a second. So let's go to, since we're looking for distance in x, let's use the motor equation. I'll put my little x's in to emphasize we're now working in x. And I'm going to rename the distance in x as range because that's another name for the distance in x. And that's what we're trying to find the range equation. All right, when we get here, can you fill this in? V sub O x. If we're going in the x direction, what can I put in? See if you can fill it in before I do. All it requires is the cosine. And then we are going to get to time. And this time says time in x. Up here it was time in y. Is there a difference between the two? Emily Keene, is there a difference between time in x? So imagine a projectile starting here and ending here. Is the time in x any different than the time in y? No, it isn't. It's the one variable that is the same. So actually, when I have time, I can erase the subscripts because it's the same for both. So therefore, I can go up and grab the time up here from our y work. Here's the line separating our x work from our y work. So when I get to time, I'm going to put in this expression. All right, since I'm working in x, the acceleration in x is 0. So that term disappears. Let's work this out with some math. If you would. Emily Davis, oops, Emily 2. There, I did it again. What can I simplify on the numerators? We're multiplying this times that.
You could do VO squared.
All right, VO squared. All right, and then I'll put sine and then cosine. And left in the denominators is just G, like that. All right, so I almost see a trig ID here, and it is helpful not to have both trig functions in my final formula, although this would work as the final formula. But mathematicians like things as concise and simplified as possible. So we're going to look and see over here, sine x, cosine x appears here and here. So if I notice there's a 2 here, so I can't do an exact substitution yet. So I'm going to mess with this. I'm going to get rid of the 2 here. So I'm going to divide this by 2 and this by 2. So now I see sine x cosine x equals sine of 2x over 2. So I'm going to substitute that in for that. So I get v sub o squared. And when I get the sine x cosine x, I'm going to put in sine of 2x over 2. The 2 goes in the bottom. And let's see if that's right. It's not. Almost right. My 2 is off. Sine of 2x over 2. The final has no 2 right here. So I wonder if I have that trig ID right. Does anyone recall? Do you recall, calc students?
Seems right to me.
Sine of 2x is 2 sine x cosine x.
It doesn't have the 2 in the top.
Where's the 2 go? Where did
Would
the 2?
it be like
Where's the 2 in the top? Pardon? There should be a 2 in the top.
Yeah, shouldn't it be like sine 2x over 2 over g?
I'll look at my
Where?
math comp book and see if I can find it.
Here, there should have been, I know, we forgot to double the time. Remember, up here? This is time to the maximum height. That's what it is. So remember, this is time to the maximum height, and we have to double it. I know there's a 2 floating around here. Alright, so let's double this. We get 2 v sub o sine f theta over g. So that 2 appears in when we plugged in time here. So now we don't have to do this who struck that I did.
Wait, what?
Uh-huh. I'll show you.
What's G?
The acceleration due to gravity.
So when I have to be like negative A?
Pardon?
Must be negative A?
Well, that's the universal symbol for it.
Okay.
So, all right. So sine of 2 theta 2x equals 2 sine x cosine x. All right. Now that I've doubled that, it created a 2 here. So let me erase that last line if you want, or you can just adjust it. So now back to you, Emily Davis. Pretend we're going through this for the first time. Can you simplify the numerators, please?
It's 2VO squared.
All right. I'll put the sine theta, cosine theta. All right, and that's over g. All right, and as you can see, there's a direct substitution now. We have a 2 in the numerator, we have a sine and a cosine. 2 sine and cosine. So I can replace this part with this substitution, and that's what I'm going to do now. So I'm going to get v sub o squared. 2 sine theta cosine theta is sine of 2x over g. This is the range equation, and that's why it works. The range equation now we're going to use for this original problem where we were shooting a projectile at 67 meters per second at 52 degrees, and we're going to see if we get anything close to what we got when we did it the long way, 450. So let's plug in the values and see. What is interesting is when we get to the equation here, v sub o squared, guess what number goes in? Is it the sine or the cosine number? It's neither. It's this number. So see how easy the range equation is?
That's what
You
confused
don't
me.
even need a sine or a cosine. So there is a sigh of relief. 67 squared sine of a double angle. So we have to double this angle. So instead of putting in 52, the formula says that we have to double the 52. So what's that? 104. And divided by g. In this problem, remember we're not putting in the negative sign because we dealt with the negative sign in the development. So it's just positive 9.8 in this case because we're working in meters. How close are we? Sometimes it's off because of rounding. So we might get 440 or 460. What is it?
444.
So it would have been rounded down to 440. If we had been 445, we would have been right on the target, 440. But it was just a rounding difference. So that is going to be our fun for today. What we're going to do is actually use this equation, so make sure you have it prominently marked on your paper. We're going to have 3 or 6, depending on our time, problems to do from our book. Yes?
So why don't you put sine theta in the above?
Right here?
Yeah, that thing.
So that's when we were working up here for time, right here. Remember when we had to get time, and that was in the y direction only. So we had to use sine.
So, but I thought that it was a given that initial velocity would be using sine theta.
In the y direction, that's true. And on your next direction, but when you use the range equation, you do not use either. You use the original,
Way over.
the original velocity.
Like the range
Yeah, we
of
better shut it down. I bet I went
Goodbye.
way over.
Yeah, we're
Okay.
probably like on